Hello and welcome. Today we are going to tackle one of the biggest, most interesting challenges in all of AI, giving it a memory. We're going to look at the incredible technology that's teaching AI not just to talk, but to actually remember. So, if you've ever used a chatbot, you know exactly what I'm talking about. You have this great conversation, it feels like it's really getting you, and then you ask a follow-up question 5 minutes later, and poof, it has absolutely no idea what you're talking about. So, what's the deal? Why are these incredibly smart systems so darn forgetful? All right, let's get right into it. The heart of the problem is this. Large language models, LLMs, are amazing conversationalists. I mean, they can write songs, they can debug code, they can explain quantum physics. But they have this one massive weakness. They have, by default, zero long-term memory. That's right. Without some kind of special tool, every single time you interact with it, it's like meeting for the first time. And that's a huge hurdle, right? If we want to build AI agents that are actually useful, like a personal assistant that knows you, or a creative partner that remembers your projects, we have to solve this problem of digital amnesia.
So how in the world do you give a digital brain a memory? Well, it turns out the answer is coming from the world of databases, but with a really cool modern twists. We're talking about a new kind of tool built from the ground up just for this challenge. The solution isn't just about storing words on a list. No, it's about storing the meaning and the context behind those words. And that requires a totally new way of thinking about how data is organized and how we get it back. And that leads us to this really critical idea, the vector database. So think about it. A normal database, it looks for exact keywords. You search for cat, you get cat. But a vector database, it organizes information based on its semantic meaning, its vibe, you could say. It allows an AI to find things that are conceptually similar, not just a perfect text match. It's a game changer. Which brings us to a major player in this new space, ChromaDB. It's an open source vector database, and it's brand new. It just came out in 2023. You'll see it called LLM native, which is just a fancy way of saying it was built from day one specifically to work with AI. It's also lightweight and flexible, which is a huge plus for developers. And it's designed around a really powerful concept called embeddings. That's the secret sauce. And look, this isn't just some theory. This is a practical tool that developers are actually using right now. They're plugging it into these popular AI frameworks you might have heard of, like LangChain and Llama Index, to build real applications that have a real memory. Okay, so we know what it is, but how does this memory engine actually work under the hood? How does it take a simple conversation and turn it into a memory that an AI can pull from later? Let's break it down. It really comes down to these three simple steps. First, you take some text and convert it into something called an embedding. You can just think of it as a long list of numbers, like a mathematical fingerprint that captures the meaning. Second, you store that embedding along with its context, its metadata. And finally, when the AI needs to remember, it uses a semantic query to find the most relevant memory. So let's look at the building blocks here. You've got the embeddings themselves, which are created by powerful AI models from companies like OpenAI or Cohere. Then you have metadata. This is super important. It's the context, like who said what, when they said it, things like that. And finally, you have something called hybrid search, which is really cool. It lets the system combine that fuzzy, meaning-based search with precise keyword search to get the best of both worlds. Okay, let's zoom out. We've talked about the mechanics, but so what? What's the real impact of giving AI a memory? Why is this such a huge deal for all of us? This quote just nails it. We're not just talking about storing data anymore. That's old news. We are building a functional, working memory for an artificial intelligence, an engine that lets it learn and adapt from every single thing it does. Seriously, this isn't just a minor upgrade. In the history of how we build these things, this is a fundamental shift. We're moving from stateless tools that have to start from scratch every single time to stateful, context-aware agents that can actually build a history with you. And the difference is just night and day. Before, you had a forgetful AI. Now, you have an AI with memory. You go from having the same repetitive conversations over and over to interacting with a truly context-aware agent. And best of all, you go from these impersonal, one-size-fits-all interactions to something that's actually personalized. This is where AI starts to feel less like a tool and more like a partner. And that really leaves us with this huge, fascinating question to think about. Once we've completely solved the problem of forgetting, the next big frontier just opens right up. If an AI can remember everything, what do we want it to learn? What should we tell it to focus on? The possibilities are just as massive as they are exciting.